In this video, we're going to look at what we mean by population mean and sample means, and then combine it with hypothesis testing in the normal distribution. So, earlier on in the course, we talked about mean and used X bar. The reason we use X bar is when we're talking about a sample, so it might be data you've collected, use that symbol. If you're talking about all the data that exists in a given population, we use mu, this symbol here. So we're going to be flicking between both of those. It's important you understand we're talking about a sample with X bar and the whole population when we're using the symbol mu. Now, if we think about a normal distribution, so if we say something's normally distributed, we're comparing the mean and we're comparing the variance, we write it as standard deviation squared. If you think about that, that's representing the whole population. That's why we call these terms here population parameters. If you were then to look at a sample, so we're now going to talk about the sample data. So that's why it's changed to X bar. What would we expect the mean to be? So if we think, for example, say tennis rackets, we're going to do a question on tennis rackets in a minute, so let's talk about that. If we talk about the weight of tennis rackets, a good standard of tennis racket should be about 300 grams. If you took every single racket that Wilson, the brand Wilson, make, you'd expect them to all be 300. But there would be some variance. If you took a sample of, say, 20 rackets, 15 rackets, maybe 50, could be 100, you would expect the mean weight to be the same. Otherwise, they wouldn't be able to sell them. So the mean actually stays the same. But if you think about comparing, say, the 100,000 rackets they make, you'd expect some variance in weights between those. So some of the machines might have been off, for example. But if you took a sample of 20 or 15 or 100, you'd expect the variance to be a lot less. So what we do, we take the variance and we find the mean average of it. So if we apply this knowledge to this question I've already prepared, we've got 120, whatever, that's the mean, and here's our standard deviation squared. If we're going to a sample of 15, that's why we've now introduced the X bar, so the mean weight of the racket, if we're staying with that concept from before, is distributed normally. We'd still have 120, and now it would be 4 squared divided by 15, because there's 15 things which we don't know. Could be capybaras, could be tennis rackets, could be, this 15 could be whatever we want it to be. So if we work this out, we have our new variance to be 16 divided by 15. Now, what you have to remember is this is the variance, that's 16 over 15. If you type this into your calculator, you get 1.06 recurring. That is your variance, and on our calculators, we always want to report the standard deviation. So I'll let's get in a habit now of square rooting it straight away. And that is quite long, but I'm just going to write it to I'm going to write it to quite a few decimal places. On the new calculator, it's incredibly hard to take those numbers and use it later. So if you write to say 4, 5 decimal places, you're going to retain the accuracy throughout. Okay, so that is how you take a normal distribution of the whole population and turn it into the sample population parameters. So let's have a look at some actual questions. So here we have a question about juice cartons. Now, the juice carton, if we skim read, we should have 60 millilitres in each of these cartons. Now, someone has been complaining, the trade-in inspector has been called in, and the complaints say they're not putting enough juice in their cartons, they're ripping the consumer off. So when the trade-in inspectors come in, they're going to do a sample, here we go, a sample of 16 cartons, and they're going to analyse the amount of juice, they've done that, and they found on average there's 59.1. So are the trade-in inspectors going to fine this company for not putting enough juice in? Or is there, if we look ahead, less than a 5% chance of that happening? So if it's within that threshold, they're not going to find them. Just maybe advise them it's a little low. If it is a 5% chance of happening and therefore really rare, they're going to be slapping a big fine on this company, and which is what they don't want. So let's they haven't defined a random variable, so let's start by doing that. So let x be a random variable, amount of juice. You should write amount of juice in the carton, but because of it, I want to keep the video a bit shorter. I'll let you do this. So that means x is distributed normally. We know it's normal. That's a continuous amount. And we have 60 is the population mean, and we've got the standard deviation up here as well, so it's 3 squared. Now, this question is talking about samples. It's also using language we've seen many times before about hypothesis tests. So we're going to go straight in and find our sample mean. That we'd expect the mean amount of juice in every carton this company makes to be the same as the amount of the 16, but we would expect less variance. Oh, something like that. 16. So this is our new variance. So we have 9 divided by 16 is our new variance. So we need to square root that to get it in the form that we want. So just type this in. And that's 3/4. Of course it is. There we go. So we're not using the original model anymore because we're taking a sample. This is the model we're going to be using. Everything that happens in the next, all my calculations in the next few minutes, we're going to use these parameters. So let's have a look. So we need to start with some hypotheses, and like all hypothesis tests, remember we know it's a hypothesis test is because of this sort of language here. We have H0, and we're saying the mean is 60. This is what the trading inspectors are investigating. And even a company, they should be doing their own tests periodically as well. But let's think about what H1 is. They've been accused of understating, so they're going to be testing whether the mean is less than 60. They're going to reject H0, and I would always recommend writing this line. They're going to reject H0 if the probability that the mean of the sample, the mean we're testing, is less than 59.1. This is, remember, the result that they said. So is the probability of this result happening less than or equal to 5% chance of happening? That's one way of looking at it. The other way, which falls in line a lot more with what you've been doing previously, is you finding the critical region. So I will draw this shape for both questions. But we are here, so this is 60. We want to know where the cutoff is in a critical region for 5%. So I'm going to do both of these methods simultaneously. So you can choose one or the other. I actually prefer this one on the right because it falls in line with the PMCC and the binomial when you're looking for numbers on a number line. I like it a lot more than just testing. The one on the left is less work. So let's go into our distribution section on our calculators, and I'm using the ClassWiz graphical calculator. So I'm going to assume everyone watching this video is, because it's the most modern calculator. And before I start, let's just draw a picture and make sure I understand what I'm trying to create. So here's 60, here's 59.1, and I want to know what the probability of that happening is. If the probability is less than 5%, I will reject H0. So I need to create this picture on my calculator. So make sure I've got the right tail. My x value is going to be 59.1. My mean is 60. And the standard deviation is 0.75. But you can also use your answer button. It should remember the full whack of that number. But for this case, it's obviously dead easy. I'm going to go ahead and create that picture. And it tells me this is 0.1151. So you can see there's actually 11.51% of this happening. We're not rejecting H0. So we're definitely going to accept H0. Good news for the company, they're not getting fined. However, if you choose to find the critical region, on the same screen that hopefully you have in front of you, if you press across to where the probability is and change it to 0.05, your picture will now look exactly the same as this. You have the 0.05, with technically the inverse norm is what we used to call it. And you'll see that this figure has to be 58.77. So in reality, a company would have known these numbers and they would have just been testing, is the mean here. They wouldn't have to do too much. They would already have this number, 58.77. Before they entered the factory, they would have weighed it and made their decision very, very quickly. This is more of a proactive approach, and the one on the left here is more of a reactive approach. So that's why I like finding critical regions. So for this one, you could have written, we're going to reject H0 if the probability of X bar is less than or equal to 58.77. So that is when we would reject H0. Okay, so because we're accepting H0, you would then have to write a conclusion. I'm going to save time in the video, but please do write it. So there's insignificant evidence or a lack of evidence to suggest that the company is understating the mean value of juicing contents. And there we have it. So let's have a look at another one. We've got two more examples. So what I would recommend you doing is maybe pausing the video, taking the question in, because I'm just going to start talking about it straight away, and maybe trying it yourself. This question's actually got a lot more going on. So it's only this last bit here that is the hypothesis test. So you should be able to do part A and part B. But if you've paused it, if you've had a go, here we go. So we know that M, the mass of the brackets, is distributed normally, and we don't have the mean. So as soon as I'm writing this, standard normal is entering my thought process. We do have the standard deviation. When you're in this situation, there needs to be another piece of information, which is here. And let's draw a picture of what we're looking at. So M, we don't know the mean. We know that 5% of the rackets are in excess of 130 grams. So that means 130 has to be on this side. And what we're looking at is this. So 5% are greater than 130 grams. It must be charged rackets, like I said earlier in the video. An adult racket is about 300 grams. So when you have this situation, when you don't have one of these, like I've just said, you've got to start thinking about the standard normal. My recommendation would always be to draw it directly underneath. Standard normal we call Z, and it uses the parameters, the population mean being 0, and standard deviation being 1. If we try and create exactly the same picture, what we can do is use the inverse normal, so changing the probability, to find out how many standard deviations 130 is above the mean. So on my calculator, I have to go back. It doesn't matter what your X value is, you can put absolutely anything in there if you're using a graphical calculator. If you're not using a graphical one, you want to be using the inverse normal function. So I'm just going to leave that. I'm going to change my mean to be 0, standard deviation to be 1. Go to the picture, and remember you need to be creating the same picture as what you're looking at. Oops, I didn't change my tail. Quickly change the tail of my picture. And once that's drawn, I can just go across to the probability and change it to be 0.5. So no matter what calculator you are using, you should be able to tell me that there are 1.6448 standard deviations above the mean to get a probability of 5%. Now, if you have that, you need to remember this formula. So our Z values is X, a score, minus the mean divided by the standard deviation. So we know at 1.6448 standard deviations above the mean, we had a score of 130. We didn't know the mean, but we do know the standard deviation is 1.2. So this is where the newer calculators are frustrating. We can't get that 1.6448 without typing it in. So let's go ahead, type this in, take it away from 130, and you get a mean of 128.0. I'm just going to write 0 through. That's enough. It's 5 significant figures. It should be fine. Right, so that's part A done. What we are in, I'll just change the colour to make sure we can see it quickly. So we know, it's M, isn't it? So M is distributed normally. Do you know what? Let's just go 128. And we know it's 1.2 squared. So let's go from there. Much easier. Right, so part B, 15 brackets are chosen. So if you're thinking about earlier, I've got a sample. It doesn't mean it's a sample mean hypothesis test until you see the language of this. And you'll notice this is part C. So part B is not talking about a hypothesis test. Part B is talking about number of brackets, which is a binomial distribution. So I'm going to write my part B just up here. So before we get going, I'm going to say let x be the random variable. You can't start introducing new letters without defining them. You can't use m anymore because m is the mass of a bracket. So the number of brackets cannot be m. So let x be the number of brackets. Now, let's just, that's fine. Number of brackets. It's not specifying a certain weight. Oh, is it? Yes, it is. Number of brackets greater than, speech marks, greater than 130 grams. Now, they could have made this question a lot harder because they've actually given us the probability of it being greater than 130 grams. So if they change that, you'd have to do a bit of a normal distribution calculation. So x is distributed binomially because we're now in discrete number of brackets. And we have 15 brackets. And what is the probability that those brackets, or one of those brackets, is greater than 130? We just circled it in green, 0.05. Let's try and get this question from words into Mathland. So find the probability that fewer than 2 of them are greater. So probability that the number of brackets greater than 130 is fewer than 2. So that's the question. We're now in discrete, so this inequality sign has to be changed. This is where we're at now. So let's go ahead and use our calculators to work this out. So go into the binomial distribution, check your tails in the right direction. 1 is our x, we have 15 and 0.5. You'll see you have a binomial picture, which is definitely not symmetrical, and your answer to B is 0.829. And I'm going to put 0 just because that would have it right into 4 decimal places for probabilities. So change the colour again for C so it doesn't get too confusing. So now, here we go. You've got this language about sample means, and we've got, again, this language about significance levels. So straight away, I'm thinking about going back to our original distribution, which is M, but now we're in the sample version. So the sample mass is distributed normally. We'd expect the mass of the brackets from the whole population to our sample still to be 128. But this time we'd expect a little bit less variance in the weight of those brackets. So we're going to have to divide it by 15. You'll notice some people will write 1.2 over root 15. I just don't like doing that. So I'm going to work out my exact variance, and then I'm going to square root it. And I make that, it's not a very nice number, but 0.3098 squared. Right, so let's go. So we have to do our hypotheses, H0. The mean is 128, and we haven't even scanned the words yet to see what's going on with this 128. So they have found the mass of the racket is less than. So again, it's a one-tailed test, less than 128. So you can choose your method. I'm going to do the critical region. So I'm going to say reject H0 if I'm going to leave this next bit. I'm going to draw my picture first. I'm going to get all the information I want. So I've got 128. We need to have a less than a 5% chance of happening. So I want to know where this cutoff is for it to be 5%. So back to the normal. You could have just tested the number they gave us, which is 127, see the probability. But I'm going to go back to the normal, change my tail to be less than. Doesn't matter what x value you have, get 128 in the mean, standard deviation to be my answer, which will take the full number that I've shortened up here, which is great. And go across to your picture and just change that probability to be 0.05. So I can now see that my cutoff point here is 127.49. So back to this bit, reject H0 if the probability that the sample mean will be less than or equal to 127.49. So there's my cutoff point. If I weigh these rackets and it's less than that, I reject H0. So where is 127? 127 is here. 127 is less than, so we are rejecting H0. So there's my conclusion. Reject H0. And again, just to shorten this video, I'm not going to write it, but I will say it. You must write it. Didn't label my axes, naughty. So there is evidence to suggest that the mass of these rackets is less than the population mean. So they're not getting fined because they're not being inspected, but if you're running this company, you need to be like, oh, our rackets are not the right weight. They are significantly out. We need to stop production, check the machinery, fine-tune everything, do another sample until we're happy to mass produce rackets. Otherwise, we could end up with a fine. That's hypothesis testing. I hope it makes sense. Please do feel free to leave any comments and I'll do my best to get back to you.